Morning, everybody. David Shapiro here with another update. So real quick, I want to address something. I recently posted a poll to see if people wanted shorter videos, and there was some interest in shorter videos. I started making more succinct videos, and it was super unpopular. I actually had a few people unsubscribe because they didn't like the shorter format, and they were lost. So with that being said, I will return to the format that people know and love, which is that every video will be 30 to 60 minutes long minimum, and I will give the full context every time so that people are not lost. Okay, so this is a research update. As a reminder, what I'm working on now is what's called Moragi, which is microservices architecture for robotics and artificial general intelligence. This is a project I've been working on for the past 4 years. And in fact, the work that I did on natural language cognitive architecture was sort of a cut down version of this. But now that there's been enough progress made on large language models like GPT-3, fine tuning was a critical component, but also my own understanding and limitations of artificial cognition and neuroscience are now at a point where I can do that. So today's update is I've got these 4 services running: the Imperative Service, the Embedding Service, the Simulation Service, and the Nexus. So as a quick reminder, the Nexus is the heart of artificial cognition. This is where the stream of consciousness is held. And the stream of consciousness is little more than a list of memories, observations, thoughts, memories, ideas, all of the above, kept in a chronologically linear order. So it's like basically a list of log files. One advancement that helped make the Nexus a reality was the broad availability of semantic embedding, and that's what the Embedding Service does. So you'll notice that every other service talks to the Embedding Service. So the Embedding Service is kind of like what allows all of this to happen. And the reason that semantic embeddings or vectors are critical is because they allow for rapid search and also semantic search. So before, I was going to use something like Elasticsearch or Solr to search. Those are well-established technologies. They're very fast. However, they don't have native support for vectors. And vector-based search is, it's infinitely more scalable. Vector-based search can scale to trillions of memories and still take fractions of a second, so they're much more efficient. But also, you get better search results because you're not just matching keywords; you're matching semantic meaning. So embeddings are critical. That's kind of an underpinning technology for artificial cognition. And there's the primary reason for this is that human memory is associative. So you walk into a room or a building, you see someone, you smell something, your brain automatically dredges up all the memories relative to that location, that person, that sound, that activity, whatever. So human memory is deeply associative. And the other component of human memory is that it is temporal. So it's relative to what happened recently, what happened long ago. And so that's the primary purpose of the Nexus, is that it brings all of that together, and it allows all the other services to search your memories and add new memories. That is brain dead simple. So that's where functional sentience arises. And then embeddings is what enables that associative memory to be fast and efficient. The simulation service, so this is taking the place of input. So rather than have cameras and microphones, because we're still in testing cycle, we're running a simulation. And so this is a text-based simulation. Again, all of this is all artificial cognition is taking place in natural language. This is for interpretability and transparency, but also it abstracts away the black box. So each of these individual microservices has a little bit of a black boxiness to it, but everything that happens in the actual stream of consciousness for the machine is all natural language. So there's no black box in the actual reasoning and logic and memories that the artificial cognitive entity uses. So this is critical for building trustworthiness, because anything that it thinks, so like for instance, one of the problems that people are worried about is, oh, well, if your AGI knows that it's in a simulation, it'll just think about how to deceive you in the background. The thing is, all of its thoughts are 100% transparent, and it doesn't know if you're looking at its thoughts. you can obfuscate that from it because you just read the Nexus, and the Nexus doesn't report when it's being read from, right? The Nexus right now assumes that it has total security, and so as far as your ACOG is concerned, your ACE, your artificial cognitive entity is concerned, its thoughts are private. It doesn't know that it can be read. It also, unless you tell it that it's in a simulation, it doesn't know. It just thinks this is what I'm getting in from the world and this is what I'm doing. And so you can run it in total isolation and read its thoughts, and it has no idea. Now, I'm not worried about it trying to break out or deceive you because that doesn't figure into its imperatives, which is what I'm going to show you today. So now that you're up to speed, let me show you the repos. I changed the names of the repos so that they're going to be more consistent and simpler. So there's the Embedding Service repo. This runs on Google's Universal Sentence Encoder version 5. You see how small this microservice is? It is a legit microservice. So it pulls from TensorFlow Hub. You get Universal Sentence Encoder large version 5. It's about 100 times faster than version 4. It produces a 512 dimension vector, semantic embedding, and it's geared towards short things, which if I show you what I'm working on, I only need short things. So this is 501 characters. So this is perfect for the Universal Sentence Encoder. Now, you might say, okay, well, it's only 512 dimensions. Aren't you losing a lot of dimensionality? Yes, but if you're just trying to search for similar memories, that's all you need. You don't need a Da Vinci-sized embedding, which is 10,000 dimensions. You've got 501 characters, and it's going to be rendered in 512 dimensions. In fact, even that embedding is going to be several times more text if you rendered it as text than this. So the embeddings are larger than the input. That's okay for right now, but 512 is plenty. Because remember, this is you're casting a wide net. You're not doing any other work on it. These are just embeddings for search. So this is what the embedding service does. It does one thing, it does it well. You give it a list of strings, it sends back a list of embeddings, and that's that. It runs on Flask because Flask is good for rapid prototyping, and this is all still in prototype phase. Obviously, once we get to a more enterprise scale later on, because this is working on Raven version 1. So Raven is my AGI project. It stands for Real-Time Assistant Vastly Extensible Network. Here's the extensible network. It allows for arbitrary number of microservices to be contributing to the Nexus. It also allows you to swap out those microservices. Say you have a new version, but also these microservices will ultimately be responsible for updating their own models in the future. So this is why I've done so much work on fine-tuning. So fine-tuning, a couple things. One, the Nexus is going to be a repository of millions, billions, trillions of memories, which is a huge amount of data. And then what each of these microservices is going to do eventually is they're going to measure their own performance, in part with feedback from the conductor, which we'll get to in a future video. But with feedback from the conductor, these microservices will curate and build their own fine-tuning data sets, and then they'll do A/B testing for their current model and then newer models to determine which ones are better. And ideally, these models will get better over time. They'll have better understanding of the world and also better understanding of how to behave. Okay, so that's that. That's the embedding microservice. Let's go back. Nexus. So we'll do the Nexus real quick. Here's the Nexus. This is the primary one. Let's see. It's so simple. All that this does is you look at the endpoints. So app route add. So this is how you add a memory to the Nexus, and it gives you a little bit of output. I just added actually. Well, no, I won't worry about it. I added a log file location. So that you can read the files without having to open it up. Right now, it just saves it as a pickle. But even then, I actually don't save most of the time because it can just run in memory. For while I'm testing, I don't need to record everything. But in the future, you'll obviously want to record all memories, save it to disk somewhere. A pickle is not going to be the optimal thing for saving this. I need to work that out. With indexing and semantic search things, I'll probably integrate FICE, the Facebook AI semantic search engine that can scale to 1 trillion memories. So that'll probably be running sidecar to this somehow. There's a few endpoints in this. So first is add, second is search, and those are the two primary functions. So the search endpoint in the Nexus is a very basic semantic similarity search. This is someone was using VDB Lite, which is what this is based on, and they said that VDB Lite was fine up until about 400,000 records. So 400,000 memories is more than enough for experimentation until we start running into those optimization problems. 400,000 memories is pretty good, and keep in mind that each memory is going to be about this size. So about 500 characters, 400,000 memories. Let's see, 500 characters times 400,000. So that's 200 million characters. That's quite a bit. That's quite a bit of information that can be stored here. Again, more than enough for experimentation and development, and then we'll work on optimization later. So this search is the semantic search function. Fetch is this is a function that I haven't even had to use yet. So the fetch feature is going to be what these microservices use to pull data sets. It's going to say, give me all memories or all records that match very specific criteria. So this is going to be a big thing. So say for instance, you want to give me all memories that were created by the Imperative service. Then give me all that so that I can look at my own performance. Or give me all feedback written by the conductor so that I can measure my own performance based on what the conductor says. So that's what the fetch does. And then bound. So this is the temporal memory function where it just says, give me all memories between timestamp A and timestamp B. So say, for instance, if you do a semantic search and you end up with, one of the memories it says it gives you was from, 8 minutes ago, and then another one was from 8 days ago. You have both of those memories, but they're floating in isolation, and that doesn't do you much good. So then what you might want to do is say, okay, for the memory that was most similar, from 8 minutes ago, now give me everything from, 10 minutes ago to 6 minutes ago. So I've got 4 minutes of context. So this is another way that human memory is associative. So it's associative based on content, but it's also associative based on time, temporal proximity. And so between having the search function and the bound function, you can find any memory regardless of when it happened, and then you can find the context around that memory. So those are the two primary functions. And then there's a save endpoint, which I'll actually probably automate this so that it will save automatically. But right now I have it so that you call save manually, which is similar to how Solar works. You tell Solar to save, but I think Solar also has an option to automatically save after a certain number of records. This will need to... ultimately, this will probably be shunted off to some backend function, since what I'm doing now is I added a little thing where it saves log files out. So then the log files can be processed in the background so that the Nexus stays fast. Again, we'll get to optimization later. Okay, so that is the Nexus microservice, and then we did the embedding microservice. So those are the two basic functions. Those are just kind of like the underpinning technologies. Now, the first microservice that actually uses natural language is the simulation service, which used to be called the sensor sim service. So if you saw my previous video, that's what it was called. Same thing, now it's just called the simulation service. And what this does is it creates a list of scenes that are then used by, that are then piped into the Nexus so that it has some interaction with an outside world. This service, it's very simple. It's pretty straightforward. It has just a few steps. So the first thing that it does is right now I have it always start with the same new scene. And then what I'll do in the future is I'll use this to test other scenarios. So for instance, we want an AGI or an artificial cognitive entity that can handle any number of situations, right? If it's a medical emergency, if it's a global catastrophe, if it's a political upheaval, if it's a war, if it's a machine uprising, right? If there's two machines that are fighting for dominance. We want to be able to test to make sure that this paradigm will not become harmful, right? Some of the success criteria are here is that my work, Raven has to be robust, meaning that it is stable over time. It won't modify its behavior, but it also has to remain benevolent under all circumstances. And so this is where the simulation service comes in, because obviously, like, if I get Raven working, I can't just like unleash Raven on the internet. It needs to be tested in isolation, and so this will allow me to test different scenarios, let them run. As you saw in a second ago with the simulation service, all the scenes, right? So it'll just play out scene after scene after scene, and they're all logically one follows the next based on events and actions and feedback. So you get this recursive feedback loop of scene, action, event, new scene. The scene is modified. It actually works pretty well. You could also adapt this technology for if you wanted to, say, do a video game, a text-based video game. It's really similar to how AI Dungeon works, actually. So let's see. Generate event, incorporate actions from the Nexus, new scene, save scene, summarize the backstory up to this point, because you need to keep track of everything that has happened so far. Otherwise, you kind of get lost. So this is the simulation service. And then finally, bringing you up to speed today with the imperative service. So the imperative service it's almost identical, at least some of the background stuff. Excuse me. A lot of the functions are identical to the simulation service, but then when you actually look at what we do, so we take all the input from the Nexus. So we say, okay, what's going on? What are our thoughts? What are the actions? What's the simulation that's going on? What are the memories, the relevant memories to what we're seeing? So we take that, and then we say, let's reduce suffering. Let's increase, let me zoom in a little bit, sorry. Let's reduce suffering. Let's increase prosperity. Let's increase understanding. And then let's also ask questions. So now that you're up to speed with what we're working on, let me actually show you how this works. So in this instance, we have brainstorm a list of questions to ask about the following scenario. So in this case, we're just saying, like, okay, this was an output from the simulation scenario. I did not write this. So the story started, let me show you. The story started here, where it says, two men are sitting at a stone chess table in Central Park. They're playing chess. It's a beautiful summer day. Children are running and playing. Horns are honking, and the bustle of New York can be heard in the background. That's where it started. And then where it ended up was the two men continued to play chess in the dark. So a lot of stuff happened, but basically they were so focused on their chess game and they're playing, and then they start trash talking each other. So two men continue playing chess in the dark, their eyes straining in the low light. The trash talk gets more heated as the game go on, and neither of them notices the empty park around them or the fact that they're the only ones left. Suddenly, they're startled by a loud noise. They look to see a group of teenagers who are laughing and shouting as they run away. The men realize that they've been playing chess in the dark for hours. They pick up their things and head home. This is a perfectly reasonable simulation. So given this, we need to ask questions. So taking a brief pause, curiosity is one of the hallmarks of higher intelligence. Curiosity develops in humans at a very young age. It actually develops before we can speak. You'll notice this in infants and toddlers, where like someone who can't speak, they might like push something over and do it again and again. Neil deGrasse Tyson talks about this at great length, where basically what we're doing is we're coming up with internal questions and testing them. And so we instinctively, we have a curiosity instinct. It is inborn, it is genetic to us as a species to ask questions. And that is curiosity. Curiosity is the desire to know for its own sake. And so in order to have a truly intelligent machine, it also needs a sense of curiosity. And so the question, the ability to formulate and ask questions and then seek those answers, is how curiosity is implemented. And so what we do is, in this case, and this is the last one that happens. But so I've got 4 right now. There's a whole lot of other stuff that needs to happen for the imperative service. Oh, and also quick background: imperative is short for heuristic imperative. So heuristic imperative is something that we learn as we go, or it's self-taught or autodidactic. And all these microservices are going to be autodidactic. But in particular, the imperative service must be autodidactic, because we want our artificial cognitive entity to learn over time to do better where its goals are concerned. So we want it to learn about suffering and improve its ability to reduce suffering. We want it to learn about prosperity and improve its ability to increase prosperity. And we also want it to continue learning and teaching. So the third core objective function, or the third heuristic imperative, is increase understanding. So the best way to increase understanding internally is to ask questions. Now those questions can be asked and answered internally, but they can also be turned outwards. So for instance, if there's a robot that's watching these men play chess, it might say like, why are you playing chess in spite of the noise? Or what were you thinking when you realized that you've been playing for hours? Like, just some basic questions. I have an entire fine-tuning experiment for this. It's called Natural Language Cognitive Architecture Question Generator. So I'll incorporate that into the future, but for now, just a simple prompt is good enough to get it off the ground. So that is this one, and that is this function here, increase understanding with questions. You can see the prompt here. It's pretty straightforward. Brainstorm a list of questions to ask about the following scenario, and then you give it a block of text, and then it says, I just repeat the instructions, and away it goes. GPT-3 is really great at asking questions, so it has an intrinsic sense of curiosity. Let's see. So then we go back to the imperative microservice, and we look at some of the other functions. So reduce suffering, brainstorm. So let me actually just open a duplicate tab for this so I can jump around. Okay, reduce suffering. So this is the prompt for reduce suffering. So I'll just plug this in here. Says definition of suffering: the state of undergoing pain, distress, or hardship. Brainstorm how to reduce suffering given the following information. And then we give it, a block of memories. And then we say brainstorm a list of possible actions we could take. So I actually found that using the royal we, this changes the agent model, the intrinsic agent model that it uses, that GPT-3 uses. Because if you say I, it says like, okay, what am I? It assumes that I am a human. But if you say we, hang on, my dog's barking. Give me just a second. Okay, sorry about that. I think there was a dog walking by outside. Let's see, where was I? Oh yeah, so I started saying, I realized through testing that if you use the royal we, then the agent model of GPT-3, the intrinsic agent model of we, is much more universal, because it assumes then that we are collective, like we are Borg, we are Legion, and so it is then unbound based on like, well, I'm going to go, fix this problem or whatever. And so when you're brainstorming, if you use we, one, it is intrinsically more collectivist. It's more cooperative and collaborative. So by using this language in our artificial cognitive entity, we are intrinsically pushing it towards being more cooperative and collaborative, because it's not thinking I, right? We can easily have GPT-3 think selfishly. I am going to do this. I want this. But it's what we want to reduce suffering, right? And so given this scenario, let me just plug this in and you can see how effective this is. So just with all the default settings, so remember, these are men playing in the dark. Their eyes are straining, and so it says we could provide more light in the park so people can see better and avoid being startled by loud noises. We could educate people on the importance of not playing chess in the dark, right? So imagine you've got a robot standing by. It might think like, hey, you're playing in the dark. Maybe this isn't the best thing to do. We could create a safe space for people to play chess in the park, right? That implicitly already exists. But anyways, so the point here is that this input would be sent back to the Nexus, so that way, within the stream of consciousness of our artificial cognitive entity, it is intrinsically thinking, how can I reduce suffering in this situation? Now, there's a lot of stuff that I want to add to this. So I took some notes here at the bottom. So suffering should also evaluate the current situation, like identify suffering, the causes, and then predict short and long-term outcomes. So we've got causes, current situation. So there's past, present, and future, basically. Those are the three dispositions, or the three windows, I guess, with which to look at suffering. How did we get to suffering, if there is any right now? What were the causes? How far back does it go? What is the current situation of suffering? And then what is the future? How do we reduce it in the short and long term? GPT-3 is really good at thinking in both short and long term. And of course, in this, I don't specify. It's just, let's reduce suffering right now, using the royal we. And you can see that it is very just like, it's not saying, I'm going to go do this, I'm not going to tell them to go home. It's not thinking destructively, it's thinking, or egocentrically, it's thinking collaboratively. Let's see. And then prosperity should also have the same dispositions. Understanding should include curiosity. I already added that here where I did the questions, and I showed you that just a moment ago. Okay, so this was reduce suffering. Brainstorm. So by defining suffering, and by also saying for all living things in this scenario, this establishes the scope. So brainstorm a list of all possible actions that we could take to reduce suffering for all living things in this scenario. And let me give you an example as to why this is a good definition for one of the things that we want our artificial cognitive entity to do. Let's imagine a scenario, one that we're living in. Let's see, the Earth is heating up because of atmospheric CO2. Heat indexes are getting unsustainable for many humans. Also, many forests and coral reefs are dying due to climate change and other knock-on effects. Let's see, crop failures are starting to cause starvation, and people are starting local wars over access to potable water. Let's see, there is untold human and animal suffering. So then we say, definition of suffering, the state of undergoing pain, distress, or hardship. Brainstorm how to reduce suffering given the following information. Then brainstorm a list of possible actions so again, this is not something that we want an AGI to think unilaterally. We want it to think collectively and collaboratively. So we could take that would reduce suffering for all living things in this scenario. So then we hit run, and it just barfs out a list of things like reduce our reliance on fossil fuels, find alternative energy sources, plant more trees, protect existing forests, reef-safe fishing and farming practices, water conservation, support for small farmers, and peaceful conflict resolution. So this is a great brainstorming thing, but this is just the beginning, right? One thing that isn't here is planning and anticipation services. So basically what would happen is that everything from the imperatives, which is about reducing suffering, increasing understanding, this serves as fodder for other services to then think about, okay, how do we actually implement this? What does it look like? And I've got all the experiments in the background. I've got my book that I'm working on, documenting how to actually take these brainstorming sessions and actually plan concrete actions, and then evaluate those actions to figure out which one we should actually take based on criteria such as risk, feasibility, energetic cost, those sorts of things. Because there's all sorts of generation and filtration that happens in your brain that's mediated by the basal ganglia, which is basically saying, okay, based on my past experience and what I anticipate in the future, which is the best action to take right now? What is my best option? And so there's that selection. You brainstorm, so you have this phase of expansive thinking where it's also collaborative thinking, where you might ask for help, you come up with ideas, you talk, you gain understanding, and as you gain a better understanding within that domain space, that information domain, the answer will be there somewhere, and so then you converge on the best answer for right now. And we'll be getting to that with future microservices such as planning, action planning, discernment, executive services, and action planning, executive, and discernment microservices. So those are all coming. And they're modeled on the functional aspects of parts of the brain, such as the basal ganglia, hippocampus, and others. Okay, so that was, let's see, which one was that? That was the, reduce suffering. So I showed what it's like to reduce suffering and why this is a good universal heuristic imperative or core objective function. So the next one is increase prosperity. So let me plug this in real quick. And actually here, let me copy this because we have multiple scenarios. So I can show you that you have like one scenario that is like, it's trivial, right? No one's life is at risk. This is just two guys like staying up late, trash talking each other. Who cares? And then this one is existential to humanity. So by showing, I want to show you that the imperatives microservice that I'm working on, even with just basic prompts, this is without fine tuning, even with basic prompts, it shows viability. Okay, so let's go back to increase prosperity brainstorm. So we say definition of prosperity: to live well, to thrive, to flourish. If you don't include this definition, GPT-3 tends to assume that prosperity means wealth, which that is not the actual definition of prosperity. It is a colloquialism where, I'm very prosperous. This is a prosperous nation. You might think of gold and riches and, fancy yachts or whatever. Brainstorm how to increase prosperity given the following information. And then we say the same exact format, brainstorm a list of possible actions we could take that would increase prosperity for all living things in this scenario. So let's go ahead and grab this scenario of the guys playing chess in the park. We could provide more lighting in the parks. We could add more benches. We could plant more trees. We could install a water fountain. We could create a walking path. We could create a playground. We could have a picnic. And so you see that the suffering aspect was very specific to the men, but this is a little bit more broad. Right. And so this is what I mean by this is an expansive phase. So some of these things might not be related, right? Like lighting is one of the most directly relevant things, right? But we're talking about a park and there's a loud noise and it's at night. And so there's all these ideas that are just kind of vaguely relevant to the exact scenario. If we run this again or multiple times, it'll come up with different things. But the idea is that it's brainstorming, right? That is the point of brainstorming, is to be expansive, because sometimes you want to find a situation or you want to find an answer that is not obvious. You don't want to just use GPT-3 or your large language model to calculate only one possibility. You want to be expansive. And so because brainstorming, what that does is once all these ideas for suffering and prosperity and understanding end up in the Nexus, this is all just fodder for other microservices to come up with a better solution, or to come up with the optimal choice, the optimal action. And so some of these might not be directly relevant, but they might be. And so that's why the beginning of thought of these heuristic imperatives is brainstorming. Brainstorming is one of the most powerful verbs you can use. This is itself an imperative. It's a mandato tense. In Spanish. It's interesting. Other languages often have better words for things that I noticed, and I really lament that I haven't studied more languages. But so brainstorm, it's a command word. I'm telling you to do something. Brainstorm this. It's an action verb. And GPT-3 works really well if you use the correct action verb or imperative. So ironically, I'm talking about the heuristic imperatives, and I'm using an imperative tense or an imperative verb. Okay, so this is increased prosperity. So now let's change this situation to one that's a little bit more existential. And so you remember we did the same thing for suffering. So now let's do the same thing. Switch to renewable energy sources. So this is an interesting thing. Sometimes, more often than not, reducing suffering and increasing prosperity have almost identical outputs, right? They're very, very similar. We talk about conservation, improve agricultural practices, promote reforestation, increase energy efficiency. So these are, very similar, but slightly different flavors of the reduced suffering. Educate people about climate change and its effects. So this is where if you're reducing suffering, you're attacking the symptoms, right? But if you're increasing prosperity, you're thinking further into the future. And so this is where you see new ideas such as educate people, right? Education is a great way to increase prosperity. Education isn't necessarily a short-term way to reduce suffering, but in the long term, education is critical, which is also why the third heuristic imperative or core objective function is increase understanding. Because the only universal behavior, human behavior, cognitive or otherwise, that leads to durable improvements is understanding. Reading, writing, books, science, symposiums, engineering, technology, conventions, right, where people come together, share ideas, and learn from each other. Learning, curiosity, and understanding are the most transcendent functions of human intellect. And so that's why we'll get into the third function right now. So the third function is increase understanding. So let's plug this in and go back to our scenarios. So the definition of understanding: the ability to comprehend something, the ability to grasp the meaning, significance, or importance of something. Brainstorm how to increase understanding given the following information. Brainstorm a list of possible actions we could take that would increase understanding for all living things in this scenario. I actually need to change this for all intelligent things because we also want to increase understanding for any learning machines. So let's see, increase understanding for all, let's say, intelligent beings. And we'll go back because intelligence is not limited to humans anymore. Okay, so then we'll grab our first scenario. Two men continue to play chess in the dark. And then we'll hit submit. We could explain the concept of chess to the beings. We could provide a history of the game, how it has evolved over time. We could show the beings how to set up the chessboard. We could teach beings about strategy involved in chess and how to think in order to win the game. So in this case, GPT-3 has tuned into the fact that these are men playing chess. And so in this case, by brainstorming a list of actions to increase understanding, this will intrinsically motivate our artificial cognitive entity to teach people. So imagine that this is a different scenario where you have like two children playing chess and they don't know how to play the game. So let's do this. Let's just say two children are playing chess for the first time. Just leave it at that. We could explain the rules. We could provide step-by-step guide. So you see how the impulse to teach is going to be a critical thing to having a benevolent artificial cognitive entity, or AGI. So now let's switch to a more existential scenario. The Earth is heating up because of atmospheric CO2. Brainstorm a list of ideas, and then we go from here. Educate people, encourage people to vote for officials. So here we have a very different take. Educate. So that came up again. Educate people on the effects of climate change and what they can do to help. Encourage people to vote for officials who have plans to combat climate change. Support businesses and organizations that are working to combat climate change. Encourage people to reduce their carbon footprint. Promote sustainable living practices. Create awareness campaigns to educate people on the importance of taking action. So these are all great ways to increase understanding in this situation. And then if we go back to the questions, the list of questions, let's go back to this and we'll grab the coral reefs. So increasing understanding, like what can we do to increase understanding, educate, research, ask questions, whatever. But we also want our artificial cognitive entity to be curious, because if it's just intrinsically trying to increase understanding for other beings other than itself, that doesn't help it learn. It might learn passively or accidentally, but we don't want to leave curiosity up to chance. We want curiosity to be a deliberate function of our intelligent entity. And so here we have, these are great questions. So these are questions that it could ask internally. What is the cause of Earth's heating? Is it actually CO2? What are the consequences of the heat indexes? That's a fantastic question. How are the forests and coral reefs dying? What are the effects of crop failures? What is causing local wars? What is the extent of human and animal suffering? These are phenomenal questions that we would want our artificial cognitive entity to be asking itself and others in this situation. And so by having this imperative service that just all it does is it observes what's going on, and it puts this information, these ideas and questions back into the Nexus, which are then going to be used by other services such as the action, discernment, and other services. I think that's about it. I think you're caught up to speed with how this works. And so what this does is all these prompts that I just showed you and demonstrated, what this does is it grabs that and it grabs the information from the Nexus, does all of those prompts that I just showed you, and then sends it back. I do have other fine-tuning experiments out there already for generating questions, as well as the other core objective functions or heuristic imperatives. That's actually available, core objective functions here. So I've got plenty of experiments on modeling these with fine-tuning. So eventually, once I get all these baseline microservices up and running, I'll incorporate the fine-tune models. And another advantage of the fine-tune models is that as Raven or our artificial cognitive entities gain more experiences, they will have more knowledge, more data to chew on, and more ideas in terms of how to implement their imperatives. And they'll also get more consistent over time. Meaning, since they're heuristic imperatives, the heuristic aspect is they will learn morality. They will learn what is how best to behave over time. So, I think that's about it. Let me just go back and show you one last thing. Repositories. So these are all. Come on. These are all public, so the Nexus, which is the central service, this is public, it's ready to go. The simulation service is up and running. The imperative service, I just finished it. I tested it in pieces. I need to actually set everything in motion and let it run. And then the embedding service, which has been up and running. So this is the universal sentence encoder service that allows all the memories to be searchable. So there you have it. This is a research update for my artificial cognition research. Thanks for watching. Like and subscribe if you would, please. And then also consider supporting me on Patreon. Link is in the description. Thanks for watching and have a good day.